A polymerase chain reaction, or PCR, is used to make copies of a target DNA. This can occur in the thermal cycling machine. The three main stages of PCR are denaturing, annealing, and extending. Denaturing is when the double-stranded template DNA is heated to separate it into two different strands. In the annealing stage, the temperature is lowered to allow the DNA primers to attach to the DNA. Finally, the temperature is raised again for the extending stage, and a new strand of DNA is made by the Taq polymerase enzyme. These stages continue to be repeated, doubling the number of DNA copies each time.
Restriction enzymes split the DNA into fragments at restriction sites. Restriction enzymes are found in bacteria, and their purpose is to kill viruses. The enzymes attack the viral DNA and break it into useless fragments. Like all enzymes, a restriction enzyme works by shape-to-shape matching. When it comes into contact with a DNA sequence with a shape that matches a part of the enzyme called the recognition site, it wraps around the DNA and causes a break in both strands of the DNA molecule. Each restriction enzyme recognizes a different and specific recognition site or DNA sequence. Restriction enzymes are a basic tool for biotechnology research, and they are used for DNA cloning and DNA fingerprinting.
Gel electrophoresis is created by agarose TAE solution that is dissolved by a heated buffer mixture with the well mold. Once it's solidified, the gel is loaded into the electrophoresis chamber. The well should be faced closer to the negative charge side of the chamber. Once the buffer is poured into the chamber, covering the gel about 2 millimeters above the wells, the substance can be micropipetted into the wells. Most electrophoresis chambers are charged by running constantly for 150 volts. Depending on the substances that were inserted into the wells, the charge will flow through the gel from the negative side to the positive side. This allows the molecules of the substances to flow at a different rate depending on the size of the molecules. The larger the molecule is, the slower it flows through the gel. Smaller molecules flow through the gel much quicker than the larger ones, so it is closer to the positive side of the chamber.
To conclude this video, I'm going to interpret our results. At first, we can see that the DNA in each well moved along the gel, reassuring that the electrophoresis step worked. As you can see, there were two subjects that did the PRC experiment, and those still gave two different results. Subject 1 classified as a double T lowercase non-taster, while subject 2 is a double T uppercase taster. We know this information thanks to this chart. By looking at the diagram, we can also determine that the BP, or distance, that each component of the well traveled. Subject 1 moved to 121 BP, while Subject 2 had their undigested DNA at 177 and the digested one at 221. Hopefully after this video you know a little bit more about how PRC works, how restriction enzymes work, how electrophoresis works, and how to interpret your results.